want you to do is when you look at the functions, they're called f, g, and h. Those are just their names. I'm asking you to tell me certain values of the function. But remember, with the piecewise function, it gets defined, broken up over your x-axis, meaning certain values will follow one piece, and certain values will follow a different piece. And I tell you those values right to the right of the function. So when you look at f, I tell you to use these two restrictions, meaning use the 3 if x is less than or equal to 0, but use the piece that's equal to 2 if the function is greater than 0. So the way we would use this function is if I tell you to do f of 2, what does that mean? Means x is 2. I want you to figure out what the value is for the function, meaning plug that in. Which piece would you plug it into, though? Kristen?
The bottom one?
Why?
Because the 2 is the equation goes. It's
2 is bigger than 0.
Yeah. So you're comparing this to, and she's saying you go with the bottom one because x is greater than 0. If 2 would have been smaller than 0, we would go with the top. So all I'm wanting you to do is to tell me the value of the function, meaning use this equation right here. Well, it's a boring equation.
So it would be 2.
The answer would be 2, because there is no spot to plug the x in, actually. Okay. So we're looking at the function, trying to decide which spot to plug in. So for example, when you get down to number 5, now we're using function g. Function g is split into 2 pieces. The determining number in terms of your x-axis is 3. Am I lower than or equal to 3? Or am I greater than 3? So when I'm supposed to plug in for number 5, g of 7, you have to say which of those pieces am I going to use? Does 7 go at the top or the bottom, Seth?
Bottom.
Okay. 7 is greater than 3. So Seth's saying use this piece because x is greater than 3. Because 7 is greater than 3. So if I do that, I'm going to actually have to plug in this time, though. I'm supposed to do 2x minus 1. I'm just bouncing down to try a couple of them. So I'm supposed to plug in 7 for x and simplify. And Hannah says the answer is 13.
I said that.
Oh, sorry, Emily said that. I just heard it behind you. Soft, quiet voice. That is Hannah. You're not usually soft and quiet. Yes, 7.
Number 2, the answer is 3 because it's less than 0.
So yeah, even though this function, it's just that it's a boring function. So you're right, you plug it into this one. The answer, there's nowhere to plug in. It's just 3.
How do you know it's that?
How do you know it's that?
Oh, gee. No.
So I'm looking, I'm using the letter in at the beginning to tell me which thing to use. So that tells me I'm looking over here. The fact that it's a -4, these are the 2 restrictions at the end. So if you're plugging in a number for x, the x goes right here. If you're plugging in a number less than or equal to 0, it says, use this.
So would 3 be 3?
F of 3 or number 3?
Yes.
Problem number 3?
3.
Problem number 3 would be 3, yes.
And 4.
And then 2. 4 would be 4 would be 2. 3.
No.
4 would be 2. You're correct, because a half is greater than 0.
Oh, I get it.
So which one of these for number 6?
I think we 13. 5.
I had to actually use the bottom function, but there was a place to plug the x in. I had to plug in the 7.
Oh, so like the number that's like in the parentheses is the x.
Yes.
If there is no x, it's just the number.
Right, because there was nowhere to plug the number in
So it's just.
the top function. F was just a boring function. So you're going to look at the g of x. So this is 0. So you're trying to decide, should I use the top or the bottom? How did you know to use the top, Olivia?
Because 0 is less than.
Good. So she's going to look at this function and say, I'm going to use the top, and I'm supposed to do x plus 5,
The rest of them at the top.
which means I'm plugging in 0. plus 5. My answer is
5.
5. Good.
The next one's
What if you have the case where, like on number 7, 2 times -1 is -2 minus 1, which is -3. You can't do that. But when you go to the top, it would be -1 plus 5, which would equal 4, is less than or equal to 3.
It's not. Go for it.
So, you can't like. What he's saying is that like the answer that you get has to be like greater than or equal to or something. But is you got the -1, so the -1 is less than or equal to 3, but it's less than or equal to 3.
Yeah. So you're not reading what to do with it, right? That number is just telling you she's saying which one to use. So you have to look at that, and you would actually not use the bottom equation at all on this one. You'd only use the top since it's less than 3. I wouldn't use the 2x minus 1. I'd only use the x
do
plus
this.
5.
Do you want us to put like x is greater than 3
That-
or no?
No, that is not part of the answer. That's why there's a comma in the problem.
Alright.
These commas are telling you just this is the restriction that you're going to use it under.
Equals 5 or equals 3 or
I just want to know the value. Like g of -1, when I plug it in that, I should be doing -1 plus 5. The answer is 4.
oh,
And that's it.
What was number 9?
Number 9 is just asking you to now use function h. So you're going to look at the restrictions and say, which of these should I use, the top or the bottom? With the -4, I'm going to use the top. Good, because -4 is less than -2. So I would use the top equation. And again, I'm just plugging in the -4 in for x.
You do 13.
Just do 0.5.
You could think about it as 0.5, sure, because that's the same as a half. So I need half of -4, and then -4. So my final answer is -6. Good. I'm going to give you a few seconds. Other questions on how to go through 12? I'm going to give you 2 minutes. See if you can finish those 4. All right, so now our next job with these piecewise functions, we're going to practice making them. The other day, we wrote one from a graph. And you've got a bunch of pictures of these graphs on the back. So some things to observe, boys. Some things to observe. There are 2 pieces that look different, but notice that in terms of left and right, they never overlap. So one piece happens for a little while in terms of me reading the graph from left to right, and then all of a sudden, a different piece finishes from left to right. So our job is to figure out where that break happens and what happens. The other question is, how do you tilt your line? Well, the tilt of the line comes from the equation. So take a look at number 13. Number 13 has 2 equations, and there's a restriction. It says you're supposed to have the graph show me 2x minus 3 whenever x is less than or equal to 1. So if I just told you to graph 2x minus 3, how would you do that?
Go to the y-intercept and go up 2 over 1.
Where would you go to the y-intercept?
-3.
So I would start this graph at -3, and then he said go, somebody else tell me, what did he say about going up and over?
Up 2 over 1.
Somebody
Rise
else.
and run.
I want to see if they listen to you.
What?
Rise and run of up 2 over 1. So my next point would be here. My next point would be here, and whoops, not there, here, and here, and here. Remember, it also goes down 2 over 1, because you'd want to be able to get a line that goes straight through the whole graph. Now that is a perfectly straight line. It's a positive slope of 2, and it has a y-intercept of -3. However, that's not what I'm looking for. I don't want to connect this whole line. It says only show me the line when x is less than or equal to 1. So in terms of x, x is 1 right here. So that means when you graph this line, and you draw a nice straight line through it, I want you to erase, or get rid of, or don't graph at all, everything that is not less than or equal to 1. So here would be everything I have to get rid of. This graph does include the value at 1, but it doesn't include anything to the right. It only goes to the left where x is less than 1. So that's the piece. The height is -1, but when I read this, this is x is 1, right on that part of the axis. It doesn't matter how high it is, we're just talking in terms of your x-axis.
So whatever's on the side is...
Correct. So everything to the right of that spot is what we're going to change to a different slope and a different y-intercept. What is the y-intercept of our other line?
1,
What is the slope?
3,
So where do I start?
1.
Kristen?
Positive 1 on the y-axis.
Okay.
Go up 3 and you put the 1.
Okay. So I'm going to do that as much as I can. But this graph is only supposed to get graphed everywhere that x is greater than 1. Only where x is greater than 1. So if I'm looking at my graph, that means I actually don't even want the part that's on the y-axis. Right. I don't want this guy here at all. I only want right here over. Now, does this graph include 1, according to the restriction?
No.
So when I put this spot here, I want to put at that spot an open circle as best I can. It's hard to do with my big fat marker, but I want to put an open circle if I can at the value that's on where x is 1. So again, on the x-axis, the part where it would run into that value, it would have an x value of 1 there. I want that to be open, and then I want to draw a line.
Does it have to be open on the one below too?
It doesn't need to be open on the one below because the one below it says or equal to 1. That's how we're going to know when we go to plug in values. For example, if I told you to find me f of 1, like up on the problems up above, you would use which one, top or bottom?
Top.
You'd use the top and you'd do 2x minus 3, or 2 times 1 minus 3. This is how I can check it. Answer's -1, meaning that's where it should be graphed. It's colored in there. It shouldn't be colored in up there, otherwise that would be the answer.
I hope not.
We're practicing.
I hope so.
Graphing lines sure as heck is, but this could be too. Take some practice.
Friday?
Okay, so I'm going to do it again with another line. There are 2 pieces to this. The deciding number, the cutoff, is going to be 2 in terms of left and right. So we're going to have to worry about it getting cut off at 2, but I'm supposed to graph x minus 1. So somebody other than Devin and Kristen, you've been telling me all of these. Where do I start the graph? Dylan? So I'm going to start at -1. Can you tell me where I should go with my slope to?
I think it is.
And over. Good. This should be old stuff to you guys, because you already did this last semester. Up 1 over 1, he says, is the way the graph looks. Usually with my first one, I'll also go down and back so that I can start to think about what this graph looks like. And then I'm going to look at my restriction. Before I actually draw the line, I'm going to say, which of these dots won't I need? This graph is supposed to be restricted to x's. No. Read the restriction when x is less than 2. So I want you to find on the x-axis the value for 2. This dot right here is the cutoff. I'm going to get rid of everything else that's bigger because it says less. Then I'm going to also think about that dot. Why open?
Because it's not less than or equal to 3.
Good. So that dot right there is going to change to open, and then I'm going to follow everything down. Very nice.
So a line means
It is at a height of 1. But in terms of the point it's at 2, comma 1. 2 is your x. It's hard to make that shift in your head at what you're actually looking at, but you're actually looking at an x y of 2. Yes.
If so on that line, isn't it supposed to be on a negative? Isn't it supposed to go down instead of up because it's -1?
The -1, remember, is just your y-intercept. The slope in front of the x is what determines up and down. So the fact that this has an imaginary 1 right there, it is a positive slope, so it does go uphill. It just means that it crosses through the y-axis at a -1.
Yeah, but then if you go down 1 and then you go back up 1, it'll just go back to 0.
Down 1. I go down 1, I have to go left 1, like I have to keep traveling down and over. Because this line has a slope of up 1 over 1 the whole way.
Why did you?
Wait, how do you know which?
Wait, so say it again. I guess I'm just not understanding it.
Why did you start at -1?
I started at -1. When I first drew this line, the very first thing I did was I put my y-intercept here, and then I went up 1 over 1, and I went down 1, back 1. I kept making the line using the slope of +1 over 1. And then I just happened to get rid of these because I didn't need them when I drew my line. Does that answer your question? Okay.
I don't get the open dot.
The open dot is because Chandler noticed that this graph, if I were plugging numbers in, if I were to plug in an x value of 2, which is right here, if I were to plug it in, I would not use this equation because it doesn't have or equal to underneath it. The bottom one is the one that's going to get to be closed to actually include it. The bottom one's going to have the actual value at 2. This one, it has everything up until 2, but it doesn't include 2. That's why we leave it open.
So the one without the line under it is open.
Yes,
And then the one with the line under it is
correct. Yep. So, yes. So now I'm going to do number 2, the second piece. It says 2x plus 1. So I need somebody new. You guys are both disqualified. You're disqualified too. You told me the last one. I need somebody new to tell me where to start the next piece. Or do I get to pick? Matt, will you tell me? Where should I start my y-intercept on the second piece? +1, good. And then what is my slope telling me to do? Good. So I'm going to do up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then I'm going to look at my restriction. Good. I need to erase this one. Wait, why do you have to erase it? Because it's not actually part of the graph. It was just helping me find my line. It's not actually part of it. Do I erase the next dot too? No. That's on 1. That's on an x value of 1. So I'm going to get rid of that dot. The next dot is on an x value of 2. So I'm going to get to keep it. Will it be open or closed? So this one is the start of the piece, and it goes like this. These are tricky. These are something I was just reviewing with my pre-calc students the other day. It's dark looking out there.
There's supposed to be a 40% chance of rain.
What questions do you have about this?
That was this morning when I checked. But,
So what I want you to do on the back, I want you to do it on your own. On your own is I want you to attempt to match. So you have 6 graphs and 6 piecewise equations. So your goal again, on your own, is to try to match a letter to each of the piecewise equations. So you can do this a variety of ways. Some people look at the restrictions to help them know where the break is in the two pieces. Some people look at the lines and start to think about the slopes or the y-intercepts. But I want you to imagine you were graphing number 15 and find the graph that's already done for you. You probably won't have to really look at both pieces to figure it out. I'm going to give you 6 minutes. So I'll give you a minute to think about each of them. I don't want you to spend more than 6 minutes, though. I want you to spend no more than a minute per, and then move on to the next one. And you can probably use process of elimination if you need to when you're getting down to the wire. But I'm going to give you no more than 6 minutes. If we're all done before then, we'll talk about them quicker. I want you to check your answers. If you didn't get some of these, then I want you to go back and figure out why. Final answers. See if you agree. A,
Yep.
F, B,
Yep.
B,
Yep.
D,
Yep.
C.
Yep.
Oh, return is the I got the last two mixed up.
Okay. Take a look at them and see if you can figure out why.
I know why.